Hey everybody, I'm Tommy, and this is the 8th video in the build series of videos for the MicroShop project. In this episode, I'm going to show you how I made the throat plate for the table saw, the safety paddle switches, and how I applied finish to everything. Now this is also the final video in the series. In a previous video, I mentioned that I want to build a container for the MicroShop that doubles as its base. That way, you wouldn't need any sawhorses to hold it up, and when it's being stored away, it could act as a small table or a bench. I still plan on doing that and maybe even building some other accessories, and when I do, I'll be sure to post videos for that stuff as well. Either way, whether it's your first time here or even if you've been here before, welcome to 1 Minute Workbench. To get an idea of the minimum width necessary for the throat plate, I set the saw at its widest angle and then plunged it through the top. I then removed the scrap. Tracing the saw's base highlights the areas where metal is making contact with the wooden surface. After removing the saw, I used a couple of screws to help me determine the edge of the opening in a spot that would split the difference of the metal available on that thinner side of the saw's base. Adding these marks will help me cut the opening in a way that leaves the metal exposed. That exposed metal will give the throat plate something to be mounted to, which you'll see in just a little bit here. I had to get creative while cutting the opening because my saws wouldn't fit in there very well. I could have used a jigsaw, but I wanted to take this part slow since I only got one shot at it. That said, I used a flush cut saw and a hacksaw blade to make most of the cuts. I used some sandpaper to clean up the edges. To make the throat plate itself, I traced the opening onto a scrap of wood and then cut out the shape using the jigsaw table. And again, I sanded the edges just to clean things up. I remounted the saw with the temporary mounting screws and tested the fit of the plate. Everything looked good, so I started working on the permanent mounting screws for the saw. The temporary mounting screws went through the saw's base into the wooden top. The permanent screws go through the top and actually thread into the metal of the saw's base. This will hold the saw much more securely and will be more durable over the long haul. I secured the throat plate in place using the same method. This will allow me to remove the throat plate and swap it with different ones when I need to cut angles. Finally, I plunged the saw through the throat plate. Unfortunately, I forgot to square the blade properly before plunging the cut. So I adjusted the blade and plunged it again. This time it was spot on. I wired all of the tools to the appropriate switches, just like I did the table saw switch back in part 4 of this series. Then I used wire clips to arrange the wires so that they're organized and safely out of the way of the tools. I only used screws to attach the bottom, no glue. This is so I can remove the bottom and perform maintenance on the tools when necessary. I cut these small triangles to go in the corners just to give the screws for the rubber feet something a little more substantial to screw into. They didn't hold up very well though, so I had to change my method for mounting them. After that, they did just fine. I mounted the switch for the disc sander just under the tabletop. This makes it to where it can't be turned on by accident. For all of the other tools, I built paddle switches. Building my own paddle switches out of household light switches actually saved a lot of money when compared to the idea of buying paddle switches. They can be pretty expensive. When I first installed this rod, the hole in the paddle was way too tight. So I removed it, drilled it out with a larger bit, and then gave it another go. That made it a lot better. I sanded all of the corners to allow it to move even more freely and to be more comfortable to use. One problem I noticed was that the weight of the paddle itself would actually slap the switch and turn it off even when I did not want it to. So I added small pieces of foam on either side of the switch. This provides enough resistance that the switch will not turn off accidentally, but can still easily be turned off when you intentionally press the paddle. In the last video, I mentioned that I should have applied polyurethane to this disc before applying the sandpaper, and this is why. The adhesive really stuck to the wood. On the last disc sander I built, I applied polyurethane first and let it fully cure. Changing the disc on that one is a piece of cake. This one, however, Yikes. I mean, it was a major pain to remove, and it took about an hour. I used a combination of sandpaper and a chisel to get all the adhesive off and to get the face smooth again. When that was done, I removed the fence's temporary tape measure. As you might have guessed, I was getting the MicroShop ready for finishing. So I continued disassembling all of the components, being careful to label any items for which the order might be difficult to remember during reassembly. I sanded all of the exposed surfaces with 220 grit sandpaper and used compressed air to remove the dust. I carefully removed this piece that guides the miter gauge, which of course was only held in by pen nails, no glue. I applied 6 thin coats of water-based exterior-grade polyurethane while being sure to lightly sand between the first couple of coats. I added small notes near each one of the tools as a reminder of where each tool's power switch was located. They're actually pretty intuitive, but I figured an extra layer of safety never hurts. This acrylic paint I used on the paddles is very durable and very inexpensive, only about $1 per bottle. I used some epoxy to fill any mistakes that were made along the way. Once everything was cured, I reassembled all of the components. I had applied low friction tape in part 3 of this series, but of course that all had to be removed for finishing. That said, I reapplied it to all the areas that needed it. I noticed that the low friction tape didn't slide quite as smoothly on the polyurethane surfaces as it did on the wooden surfaces. So I applied just a very small amount of silicone lubricant to the main contact areas, and that did a great job of fixing the problem. Once again, I used plastic clips to streamline the wiring. This time, it was to make sure the drill press cord was out of the way. I also added these small magnets, which just give me a place to secure the drill's chuck and any bits I might be swapping out of the chuck. I noticed that the fence wasn't clamping the table very strongly after reassembly. Then I realized it was because the polyurethane was providing too much friction and not allowing me to tighten the knob. Once again, I added some silicone lubricant to the contact surfaces, and that allowed me to easily tighten the knob. Now, even gently turning the knob makes the fence clamp down very securely. It was time to recalibrate the fence to the blade. Using a ruler, I set the fence at 6 inches and measured my piece with a caliper to ensure it was perfect. Then I added an indicator mark to the fence. In order to create a very thin line, I used a knife to cut the mark into the wood, used a marker to apply ink to the knife, and then used the knife to apply that ink to the line. With the mark in place and the fence still set at exactly 6 inches from the blade, I applied the adhesive measuring tape, being careful to line up the 6-inch mark on the tape with the indicator I had just drawn. And that's going to do it for this build series. I really hope you enjoyed it. And again, I mentioned if I build accessories or when I build accessories for the MicroShop in the future, I'll post videos for that stuff as well. Let me know what you think down in the comment section. And if you can't get enough 1 Minute Workbench, check out the brand new Patreon page. I've started posting behind the scenes content, and I have plans for other stuff like members only contest with really cool prizes. And of course, as always, until the next time I see you, I hope you have fun building something.